All right, just for a quick review here, I'm going to scroll up. We're using the product, quotient, and power properties. If you need to, hit pause, write these ones down. Product property, if you're multiplying two things inside a log, you add the exponentials, you add the logarithms. Division turns into subtraction, and a power raised to a power is multiply. Moving on with problem 3, examples. Use the properties of logarithms to rewrite and simplify the logarithmic expression. So we have log base 3 of 9 squared times 4 to the third power. So when I see this, inside the log we see a product, a multiplication problem. So we use the product property and rewrite log base 3 of 9 squared times 4 to the third as log base 3 of 9 squared plus log base 3 of 4 to the third. We then use the power property, so we take that exact same response that we had, and now we'll take this 2 exponent and it becomes a coefficient. Our 3 exponent, log base 3 of 4 to the third power, that 3 becomes a coefficient. So our power property brings the powers down and multiplies them. This is why logarithms, one of the reasons why logarithms are so handy to use in higher math. So now we can simplify. We take 2 log base 3 of 9. Keep in mind that a log is just an exponent. So what power do I put on 3 in order to get 9? That's the second power, right? 3 squared equals 9. So I can keep my 2 coefficient. I can simplify log base 3 of 9 and rewrite it as 2. I have no idea what power I need to raise 3 to get 4. So I'm just going to leave that as the number 3 log base 3 of 4. And 2 times 2 is 4. When we simplify, we can get, instead of log base 3 of 9 squared times 4 to the third, that's the same as 4 plus 3 log base 3 of 4. If I had an actual use for this right now, I would tell you, but I can't think of a reason we would do this, so it's probably in astronomy and physics. That's my best guess, but I don't have any examples off the top of my head. Log of 5 over 600. And keep in mind, with a log, if no base is written, it's assumed to be base 10. We'll keep that for down the road here and simplify. So log of 5 over 600, since it's division, 5 divided by 600, this will become log of 5 minus log of 600. To simplify that, keep in mind that 600 is the same as 6 times 100. So log 5 minus log of 600 will be log of 5 minus log of 6 times 100. But 100 is the same as 10 squared. It looks like I'm missing a parenthesis right here. So we have log 5 minus log 6 plus log of 10 squared, right? Because the product turned into a sum. Log of 10 squared is the same as 2. And I distributed my minus sign, so I have log base and common log of 5 minus common log of 6 minus 2 because I simplified log of 10 squared. Wow, that was a mouthful for some reason. All right, part C. The natural log of 2 over e to the 5th. Since it's 2 divided by e to the 5th, we're going to use a quotient property. And the quotient property says the natural log of a quotient is the difference of the natural log. So the natural log of 2 minus the natural log of e to the 5th. Natural log of the numerator minus natural log of the denominator. We can simplify. Natural log of 2 is just natural log of 2, so we leave it. But this e to the 5th, remember, the natural log is asking what power do I put on e in order to get e to the 5th? Well, that's the 5th power. So that's natural log of 2 minus 5 as a simplification for the natural log of 2 over e to the 5th. All right, so we could use this to find exact values of logs without using a calculator. And I know you still want to grab the calculator and make sure, but check it out. It's not that bad. Log base 8, a square root of 8. Now, we're going to rewrite that. The square root's the same as the 1/2 power. But a power, right? A power raised to a power, a logarithm that has a power on it, we can move that in front. That's the power property. And that's 1/2 log base 8 of 8. What power do I put on 8 to get 8? That's the first power, right? 8 to the 1 equals 8. So I'll have 1/2 coefficient times 1 to give me 1/2. What power do I put on 5 to get 25? Maybe you could answer 2 right away, but using the properties, we would rewrite 25 as 5 squared. The 2 coefficient, the 2 power becomes a 2 coefficient. And we'll have 2 times the log base 5 of 5, but log base 5 of 5 is 1. 2 times 1 is 2. And we could do this millions of times, and it seems like I'm going to, but I promise these will end eventually. The natural log of 1 over the cube root of e, we're going to rewrite. That's the natural log of 1 minus the natural log of the cube root of e. But the cube root is the same as the 1/3 power. So I can bring the 1/3 out in front of the natural log of e. Remember that the natural log of 1, what power do I put on e in order to get 1? Well, 0 is the power that I put on e, so 0 is the power, 0 is the log. 0 minus 1/3 natural log of e, but the natural log of e is 1. 0 minus 1/3 times 1 equals negative 1/3. And you can put this in your calculator exactly as it's written and check and make sure. 5 times the natural log of e cubed plus natural log of e to the 8th. I'll use the power property to bring the 3 as a coefficient in front of the natural log of e, to bring the a as a coefficient in front of the 8 in front of the natural log of e. Multiply appropriately. 15 times the natural log of e plus 8 times 1. Notice I changed the natural log of e into a 1 here, but I didn't in this first step because I want to take one step at a time. 5 times 3 gave us the 15, so I'll leave the natural log of e to simplify over here. 15 times 1 plus 8 times 1 is 15 plus 8, which I believe should be 23. And part E. We don't always necessarily expand things out in order to simplify. Sometimes we'll condense. Notice this is a subtraction. And in this subtraction, I can collect it together. Log base 6 of 72 minus log base 6 of 2. I can rewrite as log base 6 of 72 over 2. And the reason I did this is because 72 divided by 2 is 36. And I know that the power that I put on 6 to get 36 is 2. So we can easily find the logarithm by remembering they're just exponents. All right, problem 5. Problems 5 and 6 are the ones that you definitely want to practice. They will be on your exam. Use the properties of logarithms to expand the expression as a sum, difference, and or constant multiple of logarithms. So the log of 3x cubed times y squared. First we use the product property. We're multiplying inside the logarithm, we're multiplying 3x cubed and y squared. So we have 3 different things. We have the log of 3 plus the log of x cubed plus the log of y cubed. To simplify after we use the product property, now we'll use the power property. So my exponent of 3 becomes a coefficient of 3 as we simplify. My exponent of 2 becomes a coefficient of 2 as we simplify. And now this is a sum, difference, and or constant multiple of logarithms. There's no powers, nothing multiplying inside the argument. It just gives us a chance to look at them individually rather than all together. So in the natural log of the cube root of x cubed over y squared, for my first step, I'm going to rewrite the cube root as the 1/3 power and distribute. Notice that 1/3 power only goes to the things on the inside of the log, only on the argument. So x cubed to the 1/3 power, a power raised to a power we multiply. 3 times 1/3 is 1. A power raised to a power for our denominator as well. Y squared to the 1/3 becomes y to the 2/3. Now that we've simplified the cube root of x and y to powers, we can use the quotient property. Rewrite the natural log of x over y to the 2/3 as natural log of x. Wow, I just said it wrong. The natural log of x over y to the 2/3 is the natural log of x minus the natural log of y to the 2/3. And finally use the power property, bring that 2/3 in front as a coefficient. Now the argument for each logarithm is a single individual variable, no powers, no coefficients, no division, no multiplication, nothing else going on. After we finish this problem C, I'm going to tell you cheater's rules. Here we go. Log base 3 of x squared, square root of y, all over z to the fifth. When I look inside the logarithm, inside the argument, right, the part inside the log, the overwhelming operation is this division. I see a fraction. So I'm going to use the quotient property first. And it's always log, same base, so in this case log base 3. Log base 3 of the numerator minus log base 3 of the denominator. Each one gets a log. But now as I look at this first term, log base 3 of x squared, square root of y, right, my numerator, I see that there's a product. Log base 3 of x squared times the square root of y is the same as log base 3 of x squared plus log base 3 of the square root of y, and we still have this minus log 3 z to the fifth. To finish this with the power property, we can bring these coefficients, the 2 that's on the that makes the x squared becomes a coefficient. The 1/2 power that makes the square root becomes a coefficient. This 5 power on the z becomes a coefficient, so that each argument is just a single variable, no powers, nothing's being multiplied, divided, anything else going on with it. Now the cheater's rules are, anything that is positive in the answer had to come from the numerator. Anything that's negative in our separation of these, as we expand, had to come from the denominator. So I see x's and y's in my numerator. The coefficient of the log of z is negative, so it's in the denominator. Coefficient becomes exponent in each case, and I can check and make sure that I probably got it right. And most of you will get to a point where you can skip from the given problem right to this answer without doing all the steps in between. All right, here's our last example, well, a series of examples. Not only can we expand as a sum, difference, and or sum of constant multiples, we can go the opposite direction. We can condense the expression to the logarithm of a single quantity. Sometimes we want it more expanded, sometimes we want it more condensed. And we go in the opposite order. Whereas to expand, we start with the product and quotient rules and finish with the power rule. Now to condense, we're going to start with the power rule and then move on to product and quotient at the end. So depending on if it's addition or subtraction. So completely opposite idea. It's like when you simplify, you use PEMDAS, and when you solve, you go AS, MD, EP, right? You go back up the PEMDAS order. Same idea here. When you expand, you go one direction. When you contract or condense, you go in the other. So 4 times the natural log of 6 plus 3 times the natural log of x plus 1. We'll use the power property. This 4 coefficient becomes an exponent on the 6. Our 3 coefficient becomes an exponent on the x plus 1. We can now see we have the natural log of 6 to the 4th plus the natural log of x plus 1 cubed. And since we're adding 2 natural logs, we can combine them into a product. That's the natural log of 6 to the 4th times x plus 1 cubed, right, all inside the logarithm. And we can simplify to make that 6 to the 4th is 1,296 times x plus 1 to the 3rd. I would definitely not expand x plus 1 to the 3rd because that would be insane. Not that you can't do it, it's just definitely not any more simplified. There was something important I was going to tell you. Oh yes, keep in mind that the x plus 1 inside the argument, on our order of operations, the addition and subtraction's at the bottom. And when it comes to exponentials and logarithms, we step down a rung on the ladder. So we have, if an exponent is raised to an exponent, step down one, and then we have multiplication. If we're multiplying two values, we step down one on the order of operations to get addition. If we have division, it steps down one unit to give us subtraction, which is so much better on the classroom chalkboard or whiteboard, whichever. But there's nothing below addition and subtraction in the order of operations, so we cannot simplify this at all. There is nothing you can do to take care of this x plus 1 inside of the argument. It has to stay there. You can never separate the log of a sum or difference. That should have been written over here in red, big old bold print. All right, let's look at example B. 5 log 4 of z plus 2 log 4 of y minus 7 log 4 of x. Our first step is going to be the power property. So we'll take these coefficients, turn them back into exponents. We'll have log base 4 of z to the 5th plus log base 4 of y squared minus log base 4 of x to the 7th. And then we'll just take them two at a time. We'll take log base 4 of z to the 5th plus log base 4 of y squared and rewrite that as a product. Log base 4 of z to the 5th times y squared. And we still have the minus log base 4 of x to the 7th at the end, but we're only working with two at a time. We get that. Now we use the next property. It's going to be the quotient property because of the minus sign. That tells us we have log base 4 of z to the 5th y squared over x to the 7th. A single log, right, condensed into a single logarithm. We have quotients, we have products, we have powers, and it's all good. Last two examples. 2 brackets, natural log of x plus the natural log of x minus 3, close the bracket, minus 5 natural log of x plus 3. First, we're going to distribute our 2. The 2 goes to the natural log of x, and the 2 is also a coefficient on the natural log of x minus 3. We still have the minus 5 natural log of x plus 3 just kind of hanging out back here. Now that we have everything individually, we've broken apart as many grouping symbols as possible. We'll use the power property and put our coefficients, the 2, and the 5, as exponents on the arguments of the logarithms. Then we'll take 2 at a time. The natural log of x squared plus the natural log of x minus 3 squared becomes the natural log of x squared times x minus 3 squared. And we still have the minus natural log of x plus 3 to the 5th. And now we use the quotient rule because it's a subtraction. It'll come together as a division. And we have the natural log of x squared times x minus 3 squared all over x plus 3 to the 5th. All right, part D. Last one. Again, we distribute. So the 1/3 times the log base 2 of y plus 5. The 1/3 times 4 log base 2 of y minus 5 becomes 4/3 log base 2 of y minus 5, and the plus 4 log base 2 of y. Next step, move the coefficients to become exponents. Each of the times, maybe I should have typed that correctly as a 4 instead of a 5. Sorry about that. That's a 4, not a 5. The product property now says because the first two are addition, it turns into multiplication. The next one is an addition as well, so we use the product property again. And again, these values are incorrect because I made a typo on that first one, which made a typo that follows. It should have been a 5, or excuse me, a 4, not a 5. All right, properties of logarithms. We will be using these when it comes to solving exponentials and logs in the next section.